This video will be about multiplying and dividing rational expressions. So rational is a fancy way of saying fraction. Expressions is a fancy way of saying both letters and numbers, so variables and numbers. So let's practice without variables first. If we're working with fractions and we are multiplying, there's actually a couple of ways you could look at multiplying this out. First is to multiply and then reduce. So if we multiply first, 2 times 6 is 12, 9 times 5 is 45. Then we want to reduce. So we say what divides into both 12 and into 45? 3. So if we divide both of those by 3, 12 divided by 3, that would give us 4 over 15. So we multiplied first, then reduced. That's my favorite method if we're using just numbers. But when you get the variables involved, there's other methods I prefer. So second, you can cross cancel. You're looking for things that divide either in the fraction itself or in the kitty corner. So like 6 and 9, both of those divide by 3. 2 and 5, nothing divides into both of them. So 6 divided by 3 is 2, 9 divided by 3 is 3, 2 times 2 is 4, 3 times 5 is 15. So we get the same answer, just a different way to get to the same place. The last method is what I prefer when I then have variables involved. So same question, 2 over 9 times 6 over 5. I'm going to do what's called a prime factorization. I'm going to break it down into factors. So 2 is already prime. The only numbers that multiply to be 2 are 2 times 1. Well, if we get 1 involved, we don't need to worry about breaking it down. So 2 can't break down any further, but 9 can break down to be 3 times 3. Six can break down to be 2 times 3. 5 is already prime. So then we just look for anything that matches on the top row and the bottom row. We have matching 3's. And then we multiply it back together. 2 times 2 is 4. 3 times 5 is 15. So again, when it's just numbers, I actually prefer the first method, or the second. When it's numbers and variables, I prefer to break it all down. It makes it a little bit easier to find what is going to cancel out and disappear. So let's say we have 2x over 3 times 5 over 6x squared. So we're going to do a prime factorization, break it down into prime numbers only. 2 is already prime. X doesn't have an exponent, so there's only one of them. 3 is already prime. 5 is already prime. 6 is not prime. 6 is 2 times 3. And x squared, now when you have squared, there are 2 of them. That means x times x. Squared literally means multiply something by itself. So again, once we have it all broken down, we look for anything that matches from the top row to the bottom row. We have a 2 that matches with a 2, an x that matches with one of the x's. We do have matching 3's, but they're both on the denominator. It has to be top to bottom, numerator to denominator. So then we just multiply it all back together. 5 over 3 times 3 is 9. We have one x left. That would be the answer in reduced format. That's as reduced as it can be. So then they take it a step further and make it a little bit more complicated by involving addition or subtraction. So when you get addition or subtraction involved, that means we have to factor. So we've been doing our prime factorization. This time I'm using the word factor a little bit differently. So anything that does not have addition or subtraction, we'd still do our prime factorization on. 3 is already prime, so it'd stay 3. 9x could be 3 times 3 times x. Then, where we have the addition or the subtraction, we're going to have to remember all our different types of factoring. In quarter 3, it talked about all the different types of factoring. So when you have two terms only, and it's addition, your most likely option is greatest common factor. We're going to ask ourselves what divides into both 20 and into 15. So both of those divide by 5. Now when we're doing greatest common factor, that is backwards distribution. So when we write our answer, that greatest common factor of 5, the thing that divided into both of them, that goes into front of one set of parentheses, and then we figure out what goes inside the parentheses by actually dividing. 20x divided by 5 is 4x. 15 divided by 5 is 3. So that was doing greatest common factor type of factoring. Then we have bottom right, 16x squared minus 9. This time we have a subtraction sign, and we have perfect squares. 16 is a perfect square, 9 is a perfect square, x squared is a perfect square. So we are going to square root each of these, and that will help us write our answer for the factoring of this. Square root of 16x squared is 4x. Square root of 9 is 3. Now when we're doing, this is called difference. Difference is another word for subtraction of squares because they're perfect squares. So when we're doing difference of squares, it's a special form of these two parentheses type of factoring. We're making it into two binomials. So when we make it into the two binomials, we know one of them will have a plus, one will have a minus. And these square roots are what are going to go into each parenthesis. Square root of 16x squared is 4x. That goes at the start of each parenthesis since it was the first term. Square root of 9 was 3. That goes at the end of each parenthesis because it was the last term. So now everything's broken down. We've factored, we've done our prime factorization. We're looking for those things that are alike now. So I see a matching set of 3's from top to bottom. Again, if they're on the same row, even if they're matching, they cannot cancel. So these 3's could not cancel each other out, only from top to bottom. The second thing we have to watch out for when we have these binomials is sign makes a huge difference. 4x plus 3 is not the same as 4x minus 3. So the 4x plus 3 can cancel, but it would not have been able to cancel with this 4x minus 3. So now we multiply everything back together that we can. 5 is still here, 3 is still here, x is still here. So 5 times 3 is 15. We still have an x. On the bottom, the only thing left is 4x minus 3. It didn't have anything to multiply back together with. So let's do another example. Now the hardest part of these types of problems will be the factoring, especially when it's more than one term. When you have this addition or subtraction, figuring out what kind of factoring should I be using. So if you need to, you may want to go back and just review how do I factor. There's a lot of different ways to factor. So we've talked about, well, if there's two terms, negative 3x minus 12, no squared, this is probably greatest common factor. So greatest common factor, you're looking for what divides into both of them. So both of these divide by 3, and when the first term is negative, we're going to use a negative 3. So we have negative 3, then we divide. Negative 3x divided by negative 3 is positive 1x. Negative 12 divided by negative 3 is positive 4. X minus 4 on the bottom also has two terms, no x squared, so probably greatest common factor. Now in front of the x is a 1. We have that invisible 1 in front of every variable, if they don't already have a coefficient out front. So when we ask ourselves what divides into 1 and into negative 4, the only option is 1. Well, if that's the only option, we don't have to do it. We just say, okay, this stays as 1x minus 4. The second piece, right now it's not a fraction, but that's easy to fix. You can always put anything over 1 to make it a fraction. So now we have three terms. We have a trinomial, x squared plus x minus 20. So we have to remember, how do we factor a trinomial? So with a trinomial, we look for numbers that multiply to be the last term. So numbers that multiply to be negative 20 and add to be the middle term. Again, we have that invisible 1. So we want two numbers that multiply to be negative 20 and also add to be positive 1. So it's easiest to start with what multiplies. So looking at numbers that multiply to be negative 20. Well, I can immediately think of negative 10 times 2. That would make negative 20. Now, because it is a negative sign, I could switch that and say 10 times negative 2. That would also make negative 20. 4 times negative 5, or negative 4 times 5, that would also work. And you can't forget 1 and the number itself. 1 times negative 20, or negative 1 times positive 20. Those are all our possible combinations of things that multiply to be negative 20. Seems like a lot, but it's actually less than the addition. You could find an infinite number of things that add to be 1, because you can include negative numbers as well. So you could do 2 minus 1, or 3 minus 2, or 4 minus 3. So we do the multiplication because it's actually way more limited. Then we check the addition. So if I check negative 10 plus 2, does that equal positive 1? It does not. That equals negative 8, so that is not the correct numbers. This is off our list. 10 times negative 2. We check 10 plus negative 2 is positive 8, not 1, so that doesn't work. 4 plus negative 5. This one's getting closer. 4 plus negative 5 is negative 1. We just need it to be positive 1. So again, sign does matter. That one didn't quite work, but it was pretty close. And negative 4 plus 5, that equals positive 1. So that was all our possibilities. We just go through our possibilities till we find the correct one that meets both. Negative 4 times 5 was 20. Negative 4 plus 5 was 1. So now this will be written as 2 parentheses again. It's like that special case factoring we had on the last problem. That difference of squares ended up with 2 parentheses. This will as well. So those two numbers we found are going to be the end of each parenthesis, negative 4, positive 5. The beginning will be x's, because x times x makes the x squared. So both of those are x's. Again, you could put the 1 in front if you needed to. So we look for matches. 1x minus 4 matches up, so it cancels. And then you can multiply it back together. A lot of the time, though, they leave it in this factored format. Negative 3 times 1x plus 4 times 1x plus 5, technically all over 1. Now anytime you're dividing by 1, just like we could make this into a fraction by putting it over 1, we can get rid of a 1 on the denominator and just have the numerator only. And we also don't have to write those 1s in front of the x's. So the simplest form would probably look like this. Negative 3 times parenthesis x plus 4, and parenthesis, start a new one, parenthesis x plus 5. That is the most likely way that they will write the answer. We can also apply this to division. So we've done multiplication. We can also apply this to fractional division. So when you're dividing fractions, you leave the first fraction alone. You change from divide to multiply, and you use the reciprocal. You flip the second fraction upside down. So then, now that it's multiplication, now we do what we did before in this video. We're multiplying, so we do a prime factorization. Only thing that would break down would be 6. 6 can be 2 times 3, so the 2's cancel. We get 5 over 9. Because 3 times 3 makes the 9. So it's only this first step that's any different from all the multiplication work we did. So let's do an expression that now includes some variables. So we have x squared plus 7x plus 10 over x minus 6 divided by x plus 5 over x squared minus 36. So again, now we have to take care of this division. We leave the first fraction alone. We change from division to multiplication. We flip the second fraction upside down. This becomes x squared minus 36 over x plus 5. Now we get to the hard part of factoring again. So this one has 3 terms. That means we should end up with 2 parentheses. We know they'll start with x's. We want 2 numbers that multiply to be 10, but also add to be 7. Well, that would be positive 5 and positive 2. 5 times 2 is 10. 5 plus 2 is 7. X minus 6, there's only 2 terms, no squared. So this is probably greatest common factor, but again, there's this 1 in front. So the only thing that could divide into both of them is 1, so we just leave it how it is. Same thing on the bottom right, greatest common factor of 1, so we just leave it x plus 5. X squared minus 36 is that difference of squares. There's a subtraction sign. They are perfect squares. So square root of x squared is just x. Square root of 36 is just 6. And we always had one positive sign, one negative sign. So x plus 6, x minus 6. Now we cancel. X minus 6's cancel. X plus 5's cancel. And we're left with x plus 2 times x plus 6. And that is the final answer. So let's do 2 more examples. First, let's say we have x plus 3 over x plus 7 divided by x plus 7. So with the multiplication, it wasn't quite as important to make this a fraction, but with division, it's super important because we do have to flip the second fraction. So I have to put this over 1 to make it a fraction so that I can flip it upside down. This will change to multiply, and this becomes 1 over x plus 7. These cannot cancel. They're both in the denominator now. That's why it's important. If we didn't flip it, it might have looked like these cancel. Once they flipped, they're both in the denominator. They will not cancel. So we have x plus 3 in the numerator, because anything times 1 is just the thing itself, so we leave x plus 3. We have x plus 7 times x plus 7. And most likely, the way they're going to write the final answer is they're going to write this as x plus 3 over x plus 7 squared. When you're multiplying 2 of the same thing together, that's the same thing as writing squared. So most likely, they would write the answer like this. And I kind of skipped over the factoring part because I knew, since I've had a lot of practice, I was like, oh, these won't factor. But you should think it through. Would x plus 3 factor? Well, there's 2 terms, no squared, greatest common factor, but we have a 1 in front of the x, doesn't work. Since all of them had a 1 in front of the x, greatest common factor wouldn't have worked out. So we have one last type of problem. And what makes this so different is the number in front of the squared variable. That makes this factoring a lot more difficult than the factoring we've done so far. So looking at this, we should change it to multiplication first. First fraction stays the same. We change it to multiply, and we flip the second fraction upside down. Now we have to factor the 2n squared minus 5n minus 3. So when we factor a problem like this, again, there's a couple of different ways you can do it. We still know that since it's a trinomial, there's 3 terms, that this is going to end up in the 2 sets of parentheses. But to get there, we have to do a little bit of legwork. So I'm going to go just to a new page where I'm just looking at how I factor this. So to factor this, first you're going to do the first term times the last term. 2n squared times negative 3 makes negative 6n squared. So now instead of just what multiplies to be the last and adds to be the middle, we want what multiplies to be this that we got from multiplying the first times last term, and what adds to be this middle -5. So numbers that multiply to be -6n squared. So -6 could be 2 times -3, -3 times +2, 1 times -6, or -1 times 6. 2 plus -3, now we're checking to see if the addition works out. That is -1. We want it to come out to be -5, so that didn't work. -3 plus 2, and I put that should be +3, -2. I apologize, those were the same instead of being the two different options. +1 still doesn't work. 1 plus -6, that is -5. So there are our numbers that work. Now since it's n squared, we know this is 1n times -6n. So we're going to take this middle term, -5n, we're going to rewrite it as this +1n minus 6n. So we split this up to the two numbers we found. Now we're going to do greatest common factor with the first two terms and greatest common factor with the last two terms. So with the first two, what divides into both 2 and into 1? Well, just a 1, but they both contain n's, so 1n. So we have 1n, 2 divided by 1 is 2, n squared divided by n is just n. 1n divided by 1n just ends up being 1. -6n, -3, both of those divide by a -3. When the first one is negative, we want to make this negative. So we have -3. -6n divided by -3 is +2n. -3 divided by -3 is +1. So hopefully you notice that the two parentheses match. That will become the first part of your answer, but you only use it once. It's like they're merging together. The second part is everything left over outside of those matching, 1n minus 3. So there's our first one factored, 2n plus 1, 1n minus 3. Now we've got to factor the denominator. So again, I'm going to go to a new page so we can just factor this denominator. So same process, first times last, 4 times -7n squared. It's -28n squared. We're looking for it to be -12. So we multiplied 4 times -7 to make -28. Let's check the addition. 4 plus -7 is -3. We're trying to match the middle term of -12. Doesn't work. If we did -4 times +7, comes out +3. Still doesn't work. Let's see, 2 would work, 2 times 14, so 2 times -14. We check 2 plus -14, that's -12. That's the one we want. So we don't have to list everything once we find the ones we want. Now we can go up here and rewrite -12n as +2n minus 14n. And then we still bring down the last term of -7. The greatest common factor, the first two. They both divide by 2. Both have variables, so both divide by n. So we get 2n. 4 divided by 2 is 2. N squared divided by n is n. 2n divided by 2n is 1. Both on the end, greatest common factor, and divide by -7. -14n divided by -7 is +2n. -7 divided by -7 is +1. The two matching become the first part of your answer, 2n plus 1, and everything outside the parenthesis become the second part of your answer. So 2n minus 7 were both outside, become the second parenthesis. So we have 2n plus 1, 2n minus 7. So these ones are considerably more difficult to factor. There's a lot more steps that you have to remember as you go through and factor. These last two, we're going to check there are only two terms. So we look for greatest common factor. What divides into both 2 and into 7? Just 1, so we leave it, 2n minus 7. What divides into both 4 and into 5? Just 1 again, so we leave it. Now we look for anything matching, top to bottom. And anything left over, I'm going to not write the 1 in this time, n minus 3, and 4n plus 5. And that would be our final answer. So with this section, really the hardest part is remembering how to factor. So if you need help factoring, you may want to go back to quarter 3 and look at the factoring videos for quarter 3. So that concludes our discussion on multiplying and dividing rational expressions.